Okay, so today we are going to do what I would consider a final project type of analysis. We're going to go through the steps of getting to a point to answer a question. In this case, the question is, where would we go hunting for a fictitious bird? In this case, I'm calling it a snipe. We're going to go snipe hunting, and we want to know, based on certain criteria for the snipe, where would we find them and how would we access them? So we've got a couple of different criteria to base this on. I'll write them on the board. You can hear me on Zoom, but they breed below 1,500 meters in elevation. They hide and feed in hay and pasture grass and cultivated crops. They're sensitive to soil composition. And they're shy. I do some version of this for another class. If anybody has seen this before, we're going to do it in a little more depth because you guys have a lot more GIS experience than the animal ecology class that usually sees this particular lesson. But we're going to start with just a few basic rasters, and we're going to specifically today walk through doing some raster analysis. Rasters, remember, are made up of pixels, and each pixel has a piece of information associated with it. So what we're going to do is process through these rasters and try and identify the ideal areas based on these criteria that we would find these snipe. Now, doing raster analysis is like doing matrix math. So what we're going to do today is we're going to walk through the process of saying, okay, the pixels meet this criteria or they don't meet this criteria for each raster. And we'll multiply those rasters together to determine whether or not they're an ideal habitat, okay habitat, or habitat that doesn't meet one of these criteria. So we're going to take multiple rasters, process them into essentially 1s, 0s, and 2s based on how well they meet the criteria that we're interested in, and determine where we would find the areas of overlap. So if you'll open up ArcMap and bring in, we're going to search in Gallatin County today, so we'll just to see where we are, Gallatin County. We bring that in, bring in the DEM, bring in the geology, and bring in the land use. And we'll just start with these for now. Oh, come on. I'm gonna have to re-download this. I don't know what happened. All right, let me see. That looks like the land use wasn't cooperating, so I re-downloaded it. I don't know if that got corrupted by putting it on Teams. I really hope not, because I'm gonna have to run upstairs and get it. Anybody else getting that to work? It worked for you? Yeah. Okay, I probably just jumped the drive. Let me see if I can get it to work through the re-download. trying very hard to be patient with this, but it's not easy. Did you try re-downloading it, John? You got it to work, Tyler, but anybody else having trouble or getting it to work? It's not working for anybody else? Or is not having?
Wouldn't go in, so I'm just re-downloading, re-extracting.
Okay. I don't know what to do with that one. If it won't download, there's not a whole lot I can do. You know, I think I'll talk you through it for those of you who got it to work, but I can't get it to work. I've tried to download it 3 times now. I don't know why it's not working. But so I won't be able to do that one up here, but I'll talk you through it. So let's just start with the DEM. Oh, first thing we need to do, because we're doing raster analysis today, we need to turn on a Toolbox extension. You have access to it, but it's not turned on. So go up to Customize, Extensions, and we're going to use the Spatial Analyst toolbox. So just check Spatial Analyst. Make sure that's checked. If it's not checked, it will allow you to open the Spatial Analyst tool, but when you try to run it, it won't run for you. So did you get Geology to come down, Liam?
Yeah.
Okay, so let's start with the Geology then. I want to open the attribute table and look at it. MBMG code is the type of geology at the surface, which means it dictates the soil type that we're going to find in the area. So if you want to see what it looks like, we can go into properties and set the symbology, set it to categories in MBMG code, add all values, and you'll actually see the geology on there if I turn off the Gallatin County map. So we don't have the entire area of Gallatin County, but this is what we've got right now, so we're going to stick with that area. What I want to do is say inert clastic soils are the best for these snipes. So what I'm looking for in this particular area is alluvial sediments. And I happen to know that quaternary, tertiary, and Archean sediments make up good clastic soils. So what I want to do is process this out, get rid of everything in this list that is not Archean, which starts with an X, quaternary, which starts with a Q, or tertiary, which starts with a T. So the first thing I can do, we learned last week, is to select those items and export them, because this is a shapefile. We're going to turn it into a raster, but for now, it's easier to do it as a shapefile. Select by attributes, and we can do this 2 ways. We can write a combined expression to select anything that starts with a Q, a T, or an X, or we could select anything that starts with a Q and then add to the current selection anything with a T, etc. I'm going to write a combined expression. We know how to do it. What do we use, and or for a combined expression here? Which one would pick up the Q's, the T's, and the X's? And or? It's backwards. It's always the opposite of what the one you think. So you can write it as MVMG code like. I don't need a percentage sign before because everything starts with that letter. But I do need one after because we have multiple Q sediment types in here. QALO, QAF, etc. Or, and once you get that or in there, just go ahead and copy that entire sentence because we're going to do it 2 more times. We want MVMG code like Q, MVMG code or MVMG code like T, or MVMG code like X, and drop that last or. This is the expression we want that will pick up either something that starts with a Q, or something that starts with a T, or something that starts with an X. Say apply. Oh, what did I do? Oh, I forgot my end quotation. And hit apply. Ooh. Should pick up 755 records. We good? No?
When I was adding my values in,
You're headed?
yeah, it's the first step I messed up in my super. Okay, sorry. That's what I
Oh. So we want to switch this from area to MVMG code? Okay. Now your attribute, open your attribute table. We want to do this select by attribute. And just type in what I have written there. Just pop that in for you. And then just copy that and replace it with a T or X. Yep. We're looking at it by T and X. We're looking at it by the geology instead of by the area. We'll come back to the area later. All right, so what do we do with them now? We've got them selected. We want to separate these with 2 options. I'm sorry?
If you extract the data into its own
You can do that. Export it.
export.
That's one way of doing it. Data, export data. I'm going to create, actually, I'm just going to do it in this folder, but we're going to create quite a few files today. So name these a way that you're going to recognize. I'm going to call this geology underscore, and put underscores in these because with rasters, they don't like spaces. They'll holler at you if you don't use spaces. All right, let's just call it good geology. So this is a shapefile. It doesn't really matter if you don't have if you have a space in this one, but when we get to rasters, it's going to fuss at if you use underscores. And add it as a layer. Now I've just picked up my sensitivity to soils. I can take that off my list, but right now it's a shapefile. And I told you we're going to do this using raster math. So I want to convert this shapefile to a raster. Any guesses on how to do that? You've done something very similar before. We've gone from a raster to a shapefile in the past. This one's just going the other way. Our toolbox, conversion tools, raster to, I'm sorry, it's to raster, not from raster. Polygon to raster. Conversion tools to raster, polygon to raster. So we're going to take our good geology instead of reading the FID, because if you look at this, the FID is just the identifier for that polygon. What we're interested in is the MBMG code and the geology type. That's the field we need to assign as the value field. Let's use the maximum area for the cell assignment type, because what it's going to do, as it draws the raster, the perfect little square pixels are not going to overlap the shapefile exactly. So it wants to assign the pixel based on either the center of the shapefile area, where that lands, the maximum area, or the maximum area overlapping the cell size, or the maximum combined area. We don't have a priority field because we're just looking for the geology, but we do want to pay attention to the cell size. When we're doing raster math, it gets really cranky doing that matrix math if you don't use a uniform cell size. One of the files I gave you was the DEM right up front. We're going to use the DEM because we know we're looking at elevations of under 1,500 meters. So how would I tell what my cell size should be? Knowing we're going to use the DEM. Yes, very good. Under the source of the DEM, it tells us 26.049 by 26.049. We can get away with 30 because it's close enough. We're just going to stick with something that's close enough it can do the math easily. We don't want radical differences. So we'll just set our cell size to 30 meters and say, okay. Now, I have used my geology. I'm going to drag it down to the bottom and collapse it. Still have my good geology shapefile. As soon as my raster comes up with my good geology, I will get rid of that. I don't need this shapefile anymore, so I'm just going to drag it down. Now I have my geology. I'm going to rename this.
I'm going to put the settings on the conversion.
We want the good geology shapefile, MBMG code because we're interested in the geology. Cell assignment type is maximum area. It's going to cover the most part of that shapefile instead of where the center of the shapefile area is. And cell size, we can leave priority field alone because we're not going to prioritize any of this. Cell size should be 30.
All right.
So this is what your raster should look like now.
They give me error twice. I should have rushed it.
Oh, yeah. Yeah, see.
Said it was 31. I took a picture. I went somewhere weird.
And then I'm just supposed to.
Yeah.
I'll make you up like
Oh.
this today. So,
Yeah, so. It's about. Did she rename it?
you do something about this? That's a piece. Should I bring it here? Polygon raster? Didn't we do that with the geology? Oh, no, did we do that? Oh, she just named it that? Okay.
So just rename it when it comes in.
I guess if you explain it.
It's just be. Are you okay?
Yeah. Thank you.
All right, so it looks exactly the same, but this time it's a raster. We have a lot more options for working with rasters. And the first thing we want to do, since I told you we're doing this as matrix math, we can't necessarily multiply Q's, T's, and X's. So what we need to do is categorize these based on their importance. I'm going to tell you that quaternary or Q soils are the ideal habitat. Tertiary soils are, and they can live on Archean soils, but it might not be the best. So we're going to categorize those in order to prioritize them into numbers so that we can multiply them out. In order to do that, we're going to use a spatial analyst tool. So scroll down to spatial analyst tools in Arc Toolbox, and we're going to reclassify this raster. So under reclass, there's a tool called Reclassify. All this does is it takes old values and reassigns them different values. So what we want to do is take those good soils and classify them by MBMG code. I am going to label these 2 being the highest priority for Q, 1 being good enough, and 0 being, it's not really going to work out. So we're going to say the new values are anything that's Q is a 2, anything that's T is a 1, and anything that's X is a 0. So go ahead and rename these. Q's are 2, X is 0, and T is 1. These are 1.
Thank you. Oh my God. It shouldn't be that hard.
Sorry, it's hard to remember. So we're effectively prioritizing this, and I'm going to put no data at 0, 2. This is going to be my final output. Oh, I'm sorry, Ren.
No, you're good. I was just telling you that
Oh,
that's how I'm saying
and now try and run it, and it'll give you permission.
Okay. Okay.
I'm sorry, Ren.
No, you're. I must have missed that step.
So we have basically prioritized these. Q is highest priority. They are definitely going to be on those Q soils. They're going to be on the T soils, but it's not as good of an area. And we're actually taking X out of the equation altogether. We're saying, we've got enough space on the Q's and T's. We don't really need to look on the X. We're not that desperate. And since this is my final raster that I'm going to end up doing the matrix math with, I'm just going to call this soil, because this is one of my 4 criteria. And when you have that all set up, you can say OK. It should have broken you down to grouping Q's, T's, and X's. And if you open the attribute table and look at it, you'll see that your value is what you just assigned. All of the Q's are now value 2, all the T's are now value 1, and all the X's are now value 0. Now, just to show you what we're doing, I'm going to make my X's null colored, because what I want to do is say the red color in this case is my highest priority location, the green color is my moderately reasonable location, and anything with a 0 isn't going to count. And as I start creating each of these rasters, I'm going to color the ones that are areas that I expect to see my snipe, and areas that don't have the snipe or don't meet the criteria, I'm going to take the color out. So what I'm looking for is the areas where all of the colors overlap. It has to be all of the colors to meet all 4 of those criteria to be an area that we're interested in. So I've nullified the color on X, but kept it on Q and T. So the next step is to reclassify the DEM. This is a little different because this is elevation, and what we're interested in is above and below 1,500 meters. So instead of reclassifying this the way we just did and doing it one by one, let's reclassify the DEM. Sort by value. And let's hit this little classify button because it's automatically put them into, looks like 10 categories. I'm only interested in 2. I don't want 10 categories. I want 2, and I want them to break at 1,500. Think you guys can do that? My goal here is to set anything above 1,500 as a 0 or does not meet the criteria. Anything below 1,500 meets the criteria, so it'll be a 1 in my eventual matrix math. So I want to split this into 2 classes, and I want to set my break value to 1,500. And you can tell just looking at the data, the vast majority of this DEM falls below 1,500. So we're going to keep most of this area. And I'm going to call this elevation. Oh, I did that backwards. New value should be 1 for below 1,500 and 0 for above 1,500 because 0 does not meet the criteria. It's below 1,500. You guys follow why I'm applying these 0s and 1s? Yes, no, maybe? Okay. All right, so run that. You will get next. Your next raster. So in this case, I'm not interested in this purple zone because it doesn't meet my criteria. I'm going to change this color, something different from the others. Now, I've finished with my DEM. I have 2 areas where the blue overlaps the red and the green is where I can expect to find snipe because they meet these 2 criteria. I'm going to set you guys up with the 4th criteria, and then I'm going to try and figure out a way to get that land use to you. So if you'll bear with me, I'm going to jump ahead a little bit, and then we'll go backwards. So we're going to look for, they're shy elusive birds. We're going to look for, the next step is areas where they're going to be away from major roadways. They don't really want to be in really loud, noisy roadways. So the way to figure this out is let's put in the highways shapefile. Now we could run a buffer on this, but a buffer is going to create a polygon for us. And what we really want is a raster. And we also want something that encompasses the area outside of the buffer and not the buffer itself. So this is another tool in the Spatial Analyst toolbox. We want the tool, where is it? Distance, sorry. The tool distance. We want the Euclidean distance. Euclidean distance takes a feature, whether it's a point, a line, or a polygon, and in every direction, it calculates how far away it is from that feature into a raster. So if we run this Euclidean distance, we want to run it from the highways. And I'm going to call this distance. We don't need to input a barrier, but if we had something that we wanted to end at, we could input a barrier, another shapefile of some sort. We don't need to give it a maximum distance. It's just going to keep going. And again, we want our cell size to be 30. We're in such a small area, we're fine working with planar instead of geodesic. And this direction raster is optional. I'm going to have you run it just so we can look at it. So just give it a name, direction. We're not going to do a back direction. We'll just do a singular direction. This is going to do the exact same thing. In 365 degrees, it's going to tell you what direction it is away from this shapefile. So it's just, this is more just to show you. And you can say, okay, that tool is Euclidean direction if you want to run it without the distance. It's just kind of an add-on on this one. All right, my direction popped up on top of my distance. But what you can see from the direction is that it's put them in categories, north, south, southwest, etc. And it's grouped it in 360 degrees into these various groups. And you know, you can split these out however you want. You're not necessarily limited to these groupings. You can go into the symbology and you can change this. We've done this before. We can set up how we want to group it. If you were particularly interested in a southwesterly direction, you could split this out, the southwest and everything else based on that 0 to 360 degrees.
I'm sorry, I missed the values again.
Missed the values?
Yeah, sorry about that.
Did you run the Euclidean direction? Euclidean distance? Yeah, it was, and we put the direction in to run just as an extra. So there's nothing to add yet. We just ran that tool. We're just looking at how it comes out.
I just didn't see what values got put in. Okay. They just have to click distance.
Oh, okay. Okay, we don't need any barriers. Maximum distance is not going to be anything. Output cell size will set to 30. And just put direction right there. Yeah. And that's going to give you that extra direction raster. So create an additional raster. We're not going to use it. Yeah. We're not going to use it, but it's going to create one that is going to be a directional raster. It's just an additional. So we're going to use the distance, but we're not going to use the direction. I'm just showing it to you. Okay, so that's the direction raster. This is the distance raster. Again, categorized based on the distance. This is not like the buffer. This is categorized into, I think, 10 different groups right here, but this is a continuous raster. Every single 30-meter space away from the road is a different amount. So you can split this into 20 classes, and it'll get smaller. You can split it into 30, and it'll get even finer. This is a continuous raster, so every single cell has a distance, and all we're doing is breaking up how we look at it. Yes, this is in meters. So we can even set it as stretched. You can see that a little better as a stretched raster. It kind of blurs the lines. You don't think of this really as a singular distance, but what we can do with this is what we just did with the elevation. We can specify what distance we're comfortable with and remove everything else. Okay? So we're not actually going to use the direction raster. I'm going to collapse that and get it out of the way. But I want to set my distance. I think it was 1200. Oh, I'm sorry, it was 1800. So I want to set my distance to 0 for less than 1800 and 1 for anything greater than 1800. You think you guys can do that on your own? You're going to have to. I got to go get the land use. Be back in a minute.
Yeah, possibly.
Side.
Yeah, how do you get that?
Just the exact same what we did.
So what was that? Reclassify?
The two. Yeah, reclassify. And then two classes. And 0. Make it 0.
Yeah, should I use 0?
You can just pay. Just
Do what?
you're
Classes are
splitting
2
it
though,
into
right?
splitting it into one class below.
So you want 2 columns right here?
Oh, I didn't specify columns. I just
Okay, so just set this.
I don't care about. I'm not sure. I did 0 for below 1800 and 1 for above. That might be wrong.
I see what you mean. Okay. So 0 for 0, 2.
I think it's 1 for above because you want ones that are far away.
So 0, 1. And then, okay, where should we just see?
No, right. So, that'd be wrong.
Did you get that? Oh, shit.
Zero.
You're gonna click OK.
Yeah, your files show the same.
I thought it was like distance from this one.
This was for. This is for. Yeah.
I don't know. Oh,
Actually, I read that one.
no.
Yeah. I think this is color.
Okay, she just emailed us with the land use saying,
Okay, I'm sorry about that. I put it on Teams again, and I emailed it to you. So hopefully one of these methods will work. Yeah.
Do we want above 1800 to be one value?
Yes, we want above and below 1800. So again, we need to classify this one.
New value for over 1800.
It would be 0 because we want the information that is, yeah. Yes, no, you're right. I'm sorry. I'm doing elevation backwards. You're right. Away from the road is 1, close to the road is 0. Okay, so I didn't put them in the GIS folder. I put them just in today's date folder. You can try downloading those. I also emailed them. Hopefully that will work. While that's coming up, I'm going to go ahead and run the reclassify on this. Reclassify tool, my Euclidean distance. Give me a second, let me run this real quick. Classify into 2 groups. It was 1800. Did everybody run their reclassify tool like this? 2 categories, 0 is 0 to 1800. 1800 to 39,000 is 1. So that's our safe distance. That's our 3rd raster. And again, I'm going to set my color to non-existent where it's overlapping. My distance is done. I'm done with that shapefile. Now I'm going to try and get, for the last time, these files. John, did you try downloading it from your email as well?
Yeah. Yeah, I tried my flash drive too. So
you tried your flash drive? You don't want
yeah.
it? Your guys is working?
Anybody else get it to work?
Yeah.
You got land use to work?
Yeah. Both the one that was in the original OneDrive stuff and the new one seem to be the same. So
So I really have no idea why it's working for half of us and not working for the other half. This doesn't make any sense. All right, well, I'm going to talk you through it. If you can't get it to work, would you mind just standing behind somebody who can? I have to talk you through it because I can't do it up here. All right, we want to reclassify the land use. It should have come up on your screen listing all the different types of land use. So it's got, I think, like 36 different categories of how, like deciduous forest and stuff like that. What we're interested in is hay and pasture lands and cultivated crops. So we want to reclassify this one as well into ones and zeros. When you hit reclassify and select land use, it's going to give you a bunch of numbers. It's reading from the values in your data set, in your attribute table. You need to reset that, what is it called? You need to reset the reclass field to land use. So drop that menu there, reclass field to land use, and it should show up with all the different names in there that are showing up on your map. Land cover, I'm sorry, not land use. Land cover. Now what I want to do is set everything except hay and pasture and cultivated crops to 0. Hay and pasture and cultivated crops are set to 1. Those are our priority fields.
Just like peek through, and when I switched mine to land cover, my old values didn't switch to. They just stayed as sectors. Yeah, I'll just go back and yeah. So I'll hit land use. Land cover. Can I get it?
I just wanted to look at it.
Sorry.
No, you're fine.
I just had to do it again.
You're fine. Sometimes it just wants me to stand there and watch.
Yeah. So, what did she say?
I want to set the reclass field to land cover, and I want to set hay and pasture grasses and cultivated crops to 1, and everything else is 0.
It's just
Hay and pasture and cultivated crops are the 2 areas where they hang out and feed. Everything else is bad habitat for snipe. Yeah, reclass field is land covered. And that'll make those names show up instead of the numbers. It's reading the wrong column, it's reading the values instead of the names. Hay and pasture and cultivated crops are 1, and everything else is 0. You can call this one habitat when you create that raster. We okay? Did everybody run that? All right. So now we have 4 rasters that are set up. Our elevation gives us our breeding grounds. Our habitat gives us where they hang out and feed. Our soils came from our geology, and our safe distance came from our highways. We have 4 rasters that have been broken down into 0s, 1s, and 2s. Now we want to multiply those 4 rasters together to find out where they all meet the criteria. So the reason raster math works here and the reason matrix math works here is because if it's a 0 in any one of those 4 criteria, it's going to be a 0 across the board in that location. So each one of these has to have a 1 or a 2 in order to meet the Snipe habitat criteria. So you can now do some raster math. Again, in Spatial Analyst, we want to go into Map Algebra and use the raster calculator. You're going to have 4, I'm only going to have 3. We want to take safe distance and multiply it by elevation and multiply it by soil and multiply it by habitat. We have 4 sets of 1s and 0s where it either meets the criteria or it doesn't. And this is going to tell us anywhere that it's a 0 in any one of these is going to fall out because multiplying by 0 always makes a 0. So don't forget to add habitat in here. And we'll call this one ideal habitat. All this is doing is running that matrix math for you on the 4 rasters you created.
Okay, I just got there. Sorry.
Okay, you're fine. So you can double click on each one of these layers, safe distance, elevation, soil, and habitat, and just put a multiplier in between each of them. We're going to multiply those 4 rasters together. I don't have habitat, so you just have to pretend it's up there. Safe distance times elevation times soil times habitat. Multiplying out all those 1s and 0s we created. Only one of these has a 2 in it. And that was the soils. So what that's going to do is it's going to, anywhere that you hit that ideal soil, it's going to be weighted at a 2, and we're going to have a higher priority location there. Can say okay to run that calculation, and once that is running, we have our ideal habitat here, and you can collapse everything else in your map to get it out of there. This is what we were going for. 0 again does not meet the criteria somewhere along the way, so they are not going to be living there. Yours is going to look different because I don't have the habitat in here. Anywhere it's purple on this map is the absolute best location to go. Anywhere it's green, it meets their criteria. They can definitely live there. They're likely to be there. Maybe not as densely populated. It's just not pristine habitat for them. You guys should not look like this because I didn't have the habitat layer to multiply in. Yours should be more limited. I'm going to have more through the rest of this because I didn't have the land use. I can't get it to work. I'm sorry, John. You and I are just going to have to deal with that. All right. So the next step. We know where they are. Let's find out where we can hunt them. We have the Gallatin cadastral data. We looked at cadastral last class. Here's Gallatin cadastral data. That's a shapefile. Our best bet at this point is to now work in shapefiles, because what we want to do is we want to trim this down to places where we can hunt and clip them out of the raster. We don't actually have to do that. We can do a raster clip instead of a shapefile clip. So let's just leave this ideal habitat as a raster. But let's go into Gallatin cadastral, open the shapefile for that. And we want to select by attributes. Federal land probably would be great, but in the interest of doing this quickly, we're going to go with state. So let's Search by attributes anywhere the name is state. Let's assume we're going to hunt on state lands. Somebody tell me how to write that code. What do I want to write here? Like percent state. Remember, state's got to be in all caps. Do you want a percent after it? Probably. And hit apply. Now let's look at what that picked up. That did pick up some USA land, so United States work. It's not all federal. Problem is we also picked up some S states. We're not interested in S states. What do we do to get those out of this selection? Remove from current selection and just throw an E in there. So that knocked me down to 296. I was at 469. I don't know what your numbers are, but they should be a little lower than mine. So we have two options here. We can export this to create a new shapefile, or if we just want to be quick about it, we can turn on editor. I'm going to turn it on for the Gallatin Cadastral. Right click, edit features, start editing. Switch my selection so that I've highlighted everything that doesn't say state or estate and delete it. Then I don't have to create a new shapefile, I just deleted it from this one. You got to turn editor on and you got to switch your selection. Otherwise you're going to delete all the states. If you're not comfortable with doing that, just leave it the way it is selected and export it, create a new shapefile. That's fine too. I keep harping on it, but there's a dozen ways to do everything. Your cadastral should look the same as mine. This is what your cadastral data should look like. So now we're looking for state land that overlaps our ideal habitat. Now, right now, we still have those zeros in our ideal habitat. So if we run a raster clip, we're still going to clip down to zeros. We're going to have to do an additional step. Probably easier at this point to export that raster to a shapefile so that we can delete all the zeros out of that shapefile. Then we will only have ones and twos for our ideal habitat and state lands, and we can clip those together. So just the opposite of what we did earlier. Let's run to conversion tools. And this time from raster to Polygon. Conversion tools from raster to Polygon. We want to set our ideal habitat. And we want to make sure the field is value, not object ID. You can let it simplify your polygons, otherwise you're going to get some really jagged edges. Whichever way is fine. But all you need to do is really give this a name. Okay, so all I did was convert this to a polygon, and this time, when I open my attribute table, it's just lumped it into ones, zeros, and twos under grid code. So I just want to delete the zeros. I just want to get rid of them. We just did that with the other shapefile. Get rid of those. We only want the 1s and 2s. Okay, so we probably have a space in the name. I just did that. Yeah, just get rid of the space. Yeah, yours just did group. Yeah. Okay, so all you need to do is select by attribute anything that's equal to 0. Instead of just selecting the grid code that says 0. So now we just want to delete those. We're going to have to turn them on. Okay, so stop editing. You want to save the previous specifier? Yeah. So then start editor again from that one. But that's really all you got to do. Right click on that to open and let it edit that. Your attribution string should still be understood.
Okay, something I just couldn't catch that. So
It was a different way.
If you didn't get your 1s and 0s and 2s grouped, if you had a whole bunch of different polygons in here, all you have to do, select by attributes, grid code equals 0, and it's going to pick up all the zeros in that list instead of just having one grouping of 0. But either way, what I want to do is get rid of those. So I'm going to save my edits from the previous one. Since I just created this, editor's not going to recognize it as something to be edited. And start editing again. Grab that grid code 0 and delete it. All right, so now I have a shapefile with ideal habitat ranked as 1 and 0. I'm going to split my colors. I'm sorry, ranked as 1 and 2. I'm done with my ideal habitat raster because now I'm working with a polygon. I've gotten rid of the 0, and I have my hunting areas in my belts and cadastral data. So now all I want to do is clip those two together, figure out where they overlap. This is a shapefile clip, so it's an analysis tool. We're not going to use the raster clip in this case. So I have a couple questions that we're going to try and answer from this. Open the attribute table. The shape area for these is not terribly useful. So let's set this up. Does everybody get these groupings, or did everybody else get the singulars? Wasn't supposed to group, it was supposed to leave them individual polygons. Yours didn't group? Okay, good. I actually, when I ran it again, it set them to multi-part features, and it wasn't supposed to do that, but I didn't uncheck it. Actually, I'm going to run that again so I can do this. I'm just going to run this again real quick. I accidentally checked this box that said create multi-part features, and that's why it lumped mine into multiple groups instead of having a listing like this. So what I actually want is a listing like this. I'm not interested in square meters here. I want to know how many acres each of these is. How would we figure out how many acres this is instead of looking at it in square meters? What would you do?
You start your editor first?
We can actually do this outside of our editor because it's a calculation. But if I was editing my attribute table, I normally would absolutely have to start an edit session. In this case, make sure editor is turned off because we're going to add a field. We're going to set it to double because we're going to do a calculation. We want a number, and we're going to call this acres. Now it's going to come up with null data because I didn't put anything in it yet. But I know what these areas are in square meters. I can do a real simple calculation to convert that to acres. Right click. We want to use our field calculator. It's okay that we're doing it outside of an edit session. But we know what the shape area is. Double click. We want to multiply that by 0.000247105 is the conversion value. So 0.00247105 acres is 1 square meter. 3 zeros, 0.000247105. You could Google this, it's what I did to make the conversion if you wanted to put it in something else like miles or something, square miles. And say, okay, it's going to calculate that for us, and now we've got acres. I am going to, just to catch up with you guys, really quick, get rid of my zeros. Why are you not getting me? Shut up. All right, so I've got my acres now. Hopefully, if you guys, you're going to have different numbers from me, so I want these to be different since you multiplied by habitat. I'd like to know how many of our hunting areas are greater than 10 acres? I'm sorry? I use the double integer type. Yep, because it gives us lots of decimal places. So you and I are going to have the same number, but everybody else is going to have a different number. How many of these places are over 10 acres? Before you query your data, you have to run that analysis clip because we want to know on these hunting lands where we're in the ideal habitat. So I've got my polygon with all of my ideal hunting land. I'm clipping it by the state land from the cadastral data. This is my final product, so I'm going to turn everything else off. This is where I can go hunting. But I want to know which of these lands, how many of these lands are over 10 acres? First of all, tell me how you would figure that out. There's a couple of ways. Any way is fine with me. And don't look at this and get upset because your number is different from mine. 396 is way too high. I think the number you're supposed to get is like 294 or something like that. I'm not exactly sure off the top of my head.
So over 10 acres or something?
How many are over 10 acres? We created this acres file. Now we want to know how many are over 10 acres.
I just went to select attribute and did my acres. I did it.
No, that's perfect. Select by attributes greater than 10. My number is going to be different. I got 167. It should be much lower than that because I didn't have habitat. So 90 might be correct. That's one way of doing it. This is actually the way I was hoping you would do it since we just learned how to do this. I'm grateful that you remembered that. the other way is you can double click and sort this list, and anything that is higher than that you can select, and it'll tell you at the bottom how many you've selected out of that list. This is the faster, easier way if you remember how to do it, especially if you've got a long list. Anybody else get 90? Anybody get 61? I ran it before class and I got 61. That's okay. Actually, that doesn't mean 90 is wrong.
I'm gonna try another way. Just so I can.
You should get the same number. It's going to grab it. There's two different methods for doing the same thing. I'm just curious, is anybody? Okay, yeah. I got 61 upstairs. That doesn't mean 61 is correct, especially since we had a little trouble with the multiplications. All right. Is everybody okay with this? Did you at least get to finding them over 10 acres? You did?
I got lost.
Okay, well, I'm going to ask one more question because we only got 3 minutes left, and then I'll come walk you through it. Last question is, write a query where we would find anything over 10 acres that's only in the ideal habitat of grid code 2. It's got to be in grid code 2, and it's got to be greater than 10 acres.
So would you do add to current selection?
That is one way to do it. You can also write a combined query using and or, which would you use in this case?
We're adding.
In this case, you use and, because we want it to meet both criteria. So it has to be greater than 10 acres and grid code equals 2. You can also do select from the current selection, grid code equals 2. That would also get you to the same place. That's effectively the same as and.
Do we have to put quotations around grid code?
Nope. Grid code, if you double click it, is a column heading. So if you put a quotation around it, it's going to think it's text.
Okay, so that's 0.
Now I ended up with 103, but if you run create a new selection, acres greater than 10 and just make sure you hit that and, grid code equals 2. You don't need quotations around 2. It doesn't need quotations for math, only for text. Only if it's supposed to hunt through your attribute table for the text. Okay, so this is kind of an extreme example of what I want you to do for your final project. I don't expect you to go to these grades of depth, but what I do want you to do is ask a question of your data, process through your data using a couple of tools, and answer that question. So quite a few of you already talked to me about what you have in mind for your final projects, and I've already given you the green light. I would like for you to, by next Thursday, hand in a written proposal so that if you are headed in the wrong direction with your final project, I can steer you in the right direction now. Your final projects are going to be due, since we don't have a final for this class, I'm going to make them do the last day of finals. Email them to me. If you have something that you can't email, just reach out. We'll figure out a way to get it across if it's too big to email. But get me your final project proposals by next Thursday so that we have some idea of where we're going. But this is the first time I've shown you like an analysis where we walk through multiple steps to get to an end result. And you have quite a few tools under your belt right now. If you have a good idea of how to work through some of those tools and do an analysis, more power to you. If you want to do something that creates something entirely new using a new tool, awesome. Refer back to that sheet I gave you about what I want for your final projects. Okay, that's it. So have a great night. Grant, I will come and answer your more questions in a second. Just shoot me a couple lines because I never remember yours at the hard yet. Just shoot me a couple lines. And just I mean, even if it's just, remember that email from that guy?
Okay.
You know, something like that.
I haven't made any progress on that. So,
Oh, look, perfect. I haven't had a chance.
I haven't either. I don't know. I'm still kind of stuck on it. So
Okay.
I'll shoot you.
Thank you. Now. Yeah, we're just gonna sit here and stare at paper. Have a good night, Tyler.
You too.
Like,
Is that a-
I think I should start naming them here.
Oh, okay, do that.
Like acres, all zero.
Okay, so we don't have, that looks like it can. Looks very similar. I think that's just, okay. So you will have some little like your crocs.
Nothing, yeah. Yeah, I know.
I was just scratching.
Oh,
I wasn't all along with the
I'm sorry. Going a little too fast. It's okay to slow me down.
No,
Wait, the land use thing kind of hung me up. So in this case, you don't have the data to multiply the integers.
yeah.
I'm just going to calculate geometry instead. And it's going to let us calculate area here instead of that long. So we'll just tell it we have to do. So it's a little different from what I told you to do.
Yeah, that's cool.
But now you have the option to run that, select by attributes. What's over 10 acres, what's over 10 acres, and in group code 2, looks like you went from the raster to the shapefile, which is fine. You just don't know what area to come in, but you can always create the area.
Yeah.
Because it's a Polygon file, it'll just do that math for you. Comfortable? Did you follow why I was turning the editor on and off? So the first time, I turned the editor on because I wanted to delete the zeros, okay? And I left it on because I wasn't being careful, and I created a new shapefile. Well, editor can't run a new shapefile that it didn't know existed when editor was started. So I had to turn editor off and turn it back on for that new shapefile. So I did that to then do the calculations. That's the only reason I was turning editor on and off. And editor has to be turned off in order to add a field. It won't let you add a field when editor's turned on. So there were just a couple little things there that was like, okay,
I just
on, off. It seems silly,
I
but
think I just selected all the zeros and switched them and extracted them
that works. That's,
to that, but then it didn't show up. I don't know.
Tyler, that is totally fine. I say it every time, and I
Yeah.
know I feel like I hurt them. Do it the way you know how to do it.
Yeah.
If I'm showing you a different way to do it, that doesn't mean it's a better way. It just means it's a different way. Do it the way you know how to do it. That's perfectly fine. So it doesn't look like you missed much. I just kind of zipped through the editor on and off. Any other question? Okay, is it about the assignment? Because I promised Grant I would come talk to you outside. I'll get to you in just a minute, Dave. I'm sorry.
Biggest thing is I totally forgot. Like I don't remember where I saved my strings. So I loaded
Okay. Okay.
Can I cut the strings out that are in school? We were something about using this, or do I need to throw this in there?
It's like you've got sort of a counting there. You have a couple, so when we did the analysis tools, you have a couple of options here. You can take this and turn it into that by using the dissolve tool. Get rid of everything inside. The tool I wanted you to use is another analysis tool. It's one we didn't necessarily, I think we did actually talk about it, but it cuts all the strings out from inside some account. So either one of these two will work to cut that out.
Okay. And then to get my silver go back in here, should I find projected or just do it's like the
Oh,
first?
I would remove that file altogether and not use it. If something happened that, if you converted that or something, or I mean projected that or something, then you don't want to fool with trying to convert it back. You want to start over. It's
So I'll
just
just
on that.
re-download that file.
Just re-download that file, or if you have data from previous classes, we've gotten it several times. It looks like it's actually showing up in there as the parcel. So try running that tool with the parcel into the Silverbook County. I think I can see it there.
Yeah.
Do You know which tool I'm talking about?
Don't we just have to select the attributes inside that are inside of it?
No, because we're not doing a clip, because a clip will cut everything outside.
Yeah.
We're doing the opposite.
It's gonna be in our toolbox.
Mhm.
And it's analysis tools, extract. It's in a different.
Which ones look familiar to you? Which ones have we discussed?
Erase, select, clip. Is it just select?
It's erase.
It's erase.
Erase because it's going to erase anything inside the lines.
I'm just gonna put it on the strings.
So that's your input. You want to erase inside Silverbill. Check your streams so you can see what happens here. Otherwise, it's going to put that. When it pops up, you'll see it. It's just taking a second. It's still running. It's just taking time.
Is that what you wanted us to do for the homework?
That's it. We'll answer the questions and then
Yeah,
send that shape
questions.
file. Yep, that's it.
So for my project, here's I took the MRDS data from their website and put it onto here, and I just want to make sure I'm doing this right. So I did the lasso selection, exported it, and now I have this that little thing. So then I exported it to Google. Yeah, just so I can do it easy.
Yeah, no, that's fine, actually. It's good that you learned how to do that, because Google is technically a GIS too.
And then what I'm trying to figure out, so I really don't know how I'm going to approach this because I want to compare the accuracies. But for some reason, MRDS duplicated every single line at least 2 times, sometimes more. Comment 9 is there twice. Comment 0 3 times. I don't know how or why. And so, I don't know, is there like an average function between 2 points? Is that a thing?
There probably is, but I think there's also an erase duplicates function.
Well, I could do that, but I'm trying to figure out the accuracy, and for some of these, like out here, the centennial, you know, centennial, they got centennial.
Oh, I see.
They got 4 centennials here,
I gotcha.
and I'm trying to figure out which one is the correct one, because that's a distance of probably about 100 feet.
Yeah. Oh, gosh, this is getting into a lot more complex than anything I've done doing that kind of thing.
I might just pick the one that's closest and run with it.
Yeah, I'm thinking there's got to be something.
Because you can see where the true line is right in here.
Yeah.
So,
Yeah. It's probably the centennial access and centennial location. You know, or who knows?
you know how in a program, this is the data that's straight from MRDS, and everything is duplicated. I don't know how. Is that going to have to be an error with GIS? Or?
It's possible. It's more likely. Can I see it in GIS?
Yeah.
See if there's multiple attributes for
Oh,
each.
and I already have it right here. Too.
So let's. This is the. So not.
And also one thing that's weird in the attribute table, all of the longitudes. Oh wait, the longitudes can be fixed. For some of them, the longitudes are all look like these. For other districts, the longitudes all display. It's just like an error thing. You show all the time. I don't know what that is.
So let's see, I'm gonna sort by the site name. It
So,
does
yeah.
look like they duplicated,
That's just how they did it.
but it looks like that's how it came in, because not all of them.
Yeah, different IDs.
Yeah,
So someone just moved it.
somebody just put multiples in there, because it would be, if GIS had done it, they would have duplicated everything. What you can probably do,
Well, I can just go through and delete because I'm only going to be able to verify. I think there's about 150 of them here ish.
what I would do
I don't know how to.
is I would, first of all, open the attribute table again. If you're having trouble with lat longs, what I would do first of all is calculate new lat longs. It knows where these are located. So if some of these are showing up and some of them aren't showing up, add 2 new fields. Calculate the x point and the y point.
Okay.
So we want to open the attribute
Let me,
table.
should I undo the clip on accident? Because I kind of did the I'll have to redo that.
Tyler, did you have another question? You waiting for me?
No.
Okay.
So let's open the attribute table on this. All right, and add, before we do anything else, add 2 fields that are double. This one. This one. I want to set it as a double.
What do you mean double?
The type is not a short integer, it's a double.
Where's this mean?
This gives us it's double is strictly numeric, and since it's going to be latitude and longitude, we don't want any alphabetic characters in it. And double gives us a huge amount of space to have decimal places and whatnot. So we have lots of positive and negative integers we can add to this. So call this latitude.
Well, so why are we
Just going to want to give it a 1.
why are we doing this again?
Did we say you were having trouble with latitudes and longitudes
Yeah.
showing up?
Oh yeah, there we go. So yeah, longitude.
So we're just going to recalculate.
Well, I think honestly, it doesn't really matter as long as they're in the program correctly. It doesn't matter what they are on this table, right?
Okay, but I was going to try and do a search distance to see if they're within a certain distance of each other. The other thing you can do is once you have the latitude and longitude, anywhere that's a duplicate site, you don't have to go by site name. You can sort them by latitude and longitude and say anything that's a duplicate character.
Yeah. Well, I still haven't decided yet what I'm going to do because I kind of also it might be useful to show how messed up this database is to show how everything is duplicated. They couldn't even duplicate them right. You know,
Okay.
they duplicate them, but they put them not exactly right next to each other. And, let's see, there was some I noticed where they're duplicated, but they're definitely off by a few feet. It's like
So they're not even listing them as the same location. So one of the things you can do is if you have a really accurate latitude and longitude, you can, with the ones that you know are duplicated, you can look at the distance between those and you can categorize them. I would definitely consider this a final project. I would categorize them as, say, greater than 50 feet is us, we'll call that, going back to ranking them, that's a 1. Greater than 100 feet is a 2. Greater than 200 feet is a 3, and just say, okay, this
and I
is
could almost
how.
color code them also.
Yeah, and that's exactly it. You color code them by that number ranking system and say, this is how bad these are mapped.
Well, one thing that's also kind of confusing, I go open attribute table, and then I go to sort by name, so I can put in the duplicates. So what we were looking at the comment before, where's this comment? So I don't know, it might just be an issue with Google Earth, because here, they're not, because like on Google Earth, you look at the comment, and it's there 4 times, but on GIS, it's only there 2 times. So like, So you have, that easier to view on here. There's something wrong with the export where it's sort of. No, it's not. I don't know. Maybe it's just an issue with how Google Earth is displaying because it shows 2 points, 2 comment. Oh wait, I figured something out. It was a bit twice, but still okay.
Yeah.
But now we still have it. Okay, so now we only have it. Okay, so I haven't doubled it twice. I just doubled it once. Or they only doubled it. Okay. No, that works. So you're saying.
And if you know the actual locations of these, I mean, you're down to just a few, you can put the actual location in there and say.
Well, that's going to be the whole thing with the project, I think, is I'm going to take the actual location for 300 lines and then compare it. And then if there was a thing where, like you're saying, I can sort them and then display a map where they're color coded.
Yeah.
And it's like red means they're more than 1,000 feet off.
Yeah, I think that's a great idea. And you can do what's called a join. If you create your new locations where they actually exist and use the exact, and I mean exact naming scheme from one of the columns from the other one. Because GIS will join those two together and recognize them as being the same thing if it has the same thing going on. So like using states, you could join data about population and whatnot versus area because it's all coded by MT or NV or FL.
So I guess then it's going to be important that they have verbatim the same name.
Yes, it has to be exactly the same as it's written in GIS.
What about, but for a lot of these, like they have all this data associated with them, but I'm obviously not going to.
No, you don't need to enter any of that extraneous data. You have to pick one, like the MRSD, give it that or that is a specific code to that one line. Or even just the site name, New York line. Just make sure you spell it exactly the same and have it typed out exactly as that. Whatever is a unique identifier, you need to give it that for the location in your new shapefiles, so that you can link those two to each other.
And then for this attribute table, is there an easy way to export this to Excel?
Yes, actually, it's a good question. Up there, that little button again to the left. Data export, or I guess it's just export in this case. Now it's going to come as a DBF. So just we call it export output 3, maybe put it in downloads, it's fine. Say OK. We don't want to add it to the map now. So now open Excel.
Oh, then you do the
Open other
file.
Yep. Just browse, and it doesn't not Excel files. We just want to tell it all files. So it's gonna, you've got export output 3, and you want the DBF, not the CPG. There you go. That's all you need.
Okay, shoot, I should have done that because I got rid of the original clips that I made, so I'm gonna have to create those again to get the Excel done. Yes.
You might want to limit this down a little more. I think you had 224. I would limit it to like 100, so you're not spending a huge
Oh no, because with these, I'm gonna probably have to trim out because I have 3 different districts: one in Colorado, one in Washington, and one in Nevada.
Okay.
And I'm probably gonna only be able to keep a quarter of these.
Okay, perfect. I just didn't want you to end up
Yeah.
spending a huge amount of time with the data.
Because for a lot of these, I don't have the exact location. I'm not gonna research too much.
Right, yeah. Well, I mean, even just having a sampling says something to the NRD about what's wrong with your database.
So then here's that's okay. So that's the thing where you have to go through and recalculate it to correct all of this.
I would, because it's only giving you these decimals. It knows exactly where it is, but it's only displaying this. This is what somebody entered, but the actual location isn't showing up. That's why you calculate it. Okay. So let's go back into the Park map over here, and I'll show you how to do that again real quick. So we have a new field. I believe we added that as latitude. Or honestly, you don't even need to add a new field. Yeah. So right click on latitude 1 at the top of the column heading and say field calculator. I'm sorry, calculate geometry, my bad. Yes, we want to do it outside of that session. So we want to know the X and the Y coordinate.
And Google Earth operates in WGS84.
Yes.
Okay, so we want the X.
Okay, and that will, it's just going to work again in that session. So that was actually longitude.
Wait.
That calculated longitude. So just
Yeah.
recalculate that as a Y.
Should that be? Oh,
latitude should be 45 or something like that.
Okay, yeah. Cool, so, what, I'm just trying to remember, so I should retitle this.
No, just recalculate the geometry.
Oh, so recalculate geometry.
Yep, now this time instead of the x, set it as the, or yeah, whichever it was, do the other, rather. I think it was the x coordinates listed as the y. There you go.
Okay.
So now you have the latitude, now we add another field for longitude to calculate the x coordinate.
Field. Longitude.
Wait, don't leave it as a short integer, set it as a double. That's gonna truncate your number, you don't want it to do that.
Oh, I missed the longitude wrong.
No, it's just because we already have a latitude. Oh, I see.
Anyway, I can fix that in Excel.
Yeah.
Okay, so then click on that and do calculate geometry.
And we're not worried about it being outside of an edit section.
Okay, perfect.
So now you have real latitude and longitude locations for those points,
So
not
now
what somebody entered.
I'm going to,
Export that again.
export. Let's put it on the desktop. Oh, it's a PDF. Okay, yeah. I have to do Excel.
Open it in Excel, but search for output export for this time and open the PDF. So we need to file in a different file type.
So I'm gonna make sure. Wow, we all like that.
I do the same thing.
Get rid of all of that. Okay.
So this is actually that one that it wouldn't let you delete. It's because it was reading it. Yeah, it's got a lock on it, that's all. As soon as you stop using it, the lock will disappear.
All files. Perfect. Okay. Great. So then I can get rid of these columns.
Yep, anything you don't want. And honestly, if you're not going to use those,
Yeah.
if you're not going to use those column headings, you can do that same calculate geometry on latitude and longitude column that already exists. Just make sure it's a field type that will support that long. So that handout I gave you about short integer versus long integer versus double versus all the, just make sure it can support the latitude, longitude that you want. Oh, so we just need to save it as an Excel file.
So,
GIS just doesn't talk to Excel very well because Excel keeps changing.
so XLS.
That's the most recent version. So GIS doesn't like to read the XLSX, but it doesn't. They don't talk back and forth basically. So we got to go through this extra step of reading the PDF and saving it as an XLS.
And I'm pretty much, since I didn't save the original, I'm gonna have to, because
You don't need to save it. It exists.
that I don't. Or sorry, these I have to recalculate because these I have to redo because I don't think you can't pull that information from the word.
I honestly don't know. I don't, and I get why you work in Google Earth, you're comfortable with it and it's easy, but I don't because GIS is comfortable and easy for me. So I don't know how to do a lot of stuff
No,
in
it's
Google
fine.
Earth. It doesn't mean you can't do it, it means I don't know how to do it.
I don't know if you can do it.
Yeah, one of the problems with Google Earth, for me at least, is it's pretty limited.
All right, thanks. That's covered.
Okay.
Plan on a quiz.
Quiz Thursday, so bring all of your dates, but you said you were going to be gone.
No, I think I'll be here.
Okay. Everything's always on Teams anyway, so your textbook is the only thing I can't give you. And I've been recording this whole time. Awesome. Good job, Mary.